This is Joyson Classes. I'm back again with another exciting mindmap of carbonyl compounds containing aldehydes and ketones. Let's dive into the carbonyl compounds. Let's have a look in the carbonyl compounds, what's in store for us. First is aldehydes. Second is ketones, as for carbonyl compounds. The third compound, electronic effects, reactions mechanism, and the glucose. Let's get in aldehydes. So in aldehydes, we're gonna study about the general properties, its nomenclature. Let's look at the nomenclature, which is based on IPSC system. Nomenclature for aldehydes says that is replaced with al, for example, methanol, or phenol. So instead of ane, that is a propane, when aldehyde is present, it becomes al. And carbonyl C is giving a priority. That is number one. Carbonyl C is number one. In IPSC nomenclature, that means the carbonyl compound, that is aldehyde, is present in the chain organic compounds. Then the C of the carbonyl compound, with the idea of the decay, proceed. Next is your reactions, aldehydes. So oxidation, nucleophilic addition, and condensation reaction. Let's look into the oxidation. The oxidation, again, it instaurs Collins test and chromic acid test for aldehydes. That is a sample contains aldehyde. Collins test, radius sigomer. Sample contains aldehyde. The chromic acid test, radius answer. So this is oxidation, aldehydes. Let's look at the Nucleophilic addition. So again, there's the reactions, sodium bisulfite and HCN addition. Sodium bisulfite, that is a crystallized product. HCN addition, cyanide formation takes place. Then nucleophilic addition. Condensation reaction occurs by a low condensation and carries other reactions. These are three types of reactions. Aldehydes. Let's look at this specific aldehyde. Benzaldehyde, cinnamaldehyde aldehydes, benzaldehydes, cinnamaldehyde, and methanol. Let's look in the benzaldehyde. Properties, preparation, uses, reaction with formaldehyde, IPSC. Properties. So benzaldehyde is colorless liquid, almond-like powder. Boiling point is 179 degrees Celsius, with a soluble in ethanol and diethyl. Preparation. Oxidation of solvent, that is through passes of air, nitrogen, V2O5, let's see, 50 degrees Celsius. So when toluene oxidized in the presence of air, hydrogen, right, vanadium, pentoxide, and at temperature of 50 degrees Celsius could be the the reaction and will give the benzene halide. Moses uses. So they were like almond, perfumery, used as a precursor in pharmaceutical plastics, in the manufacturing of acetylene dyes, the fission of some aldehyde, fission of nandelic acid, fission of styrene. Reaction with formaldehyde forms benzyl alcohol. And hydrogenates benzene carbonyl, name of the benzaldehyde, in case nomenclature, benzene carbaldehyde. Next is just formaldehyde. Properties: similar like olive, soluble in methyl, chloroform, miscible with alcohol, oils, insoluble in petroleum. That is a property of formaldehyde. Operation: benzaldehyde plus acetaldehyde will give formaldehyde. Uses: flavoring agent in chewing gum, ice cream, candy, beverages, perfume with a perfume for natural and sweet fruity odor. Next is ketone. So simple formula for ketone is RCOR. Nomenclature: common name system and IPC system. Let's look at common name system. Main alkyl group plus ketones. That is dimethyl ketone is called diacetyl. That's a common name system. IPC system replace A with on. Produce propanone, butanone, pentanone, etc. And lowest number will be given to the carbon of the carbonyl compound. Physical properties: boiling point, insolubility in water, higher than hydrocarbons, ethers, which shows dipole-dipole bonds, lower than alcohols, no edge bonding. Propanol, its boiling point is 322 Kelvin. Macedone, boiling point is 329 Kelvin. Solubility in water: lower members miscible and forms hydrogen bonding, whereas solubility decreases with longer alkyl chains. Means if you add more carbon to the chain, then solubility will decreases. And if you add least chains or least carbon, then the solubility will increases. They do hydrogen bonding. Reactions: nucleophilic addition reaction, sodium bisulfite, slice product will form. Sodium hydroxide test, Radicalization will form with the sample contains carbonyl compound. Specific ketones, acetone, propanone, methyl ketone, pentane 2-on, methyl ketane 2-on. These are the specific ketones. Let's look at tests for carbonyl compounds. There are various tests. First, start with 2,4-dinylic hydrogen. Test. Give orange yellow precipitate. If the carbonyl group is present. Sodium bisulfite test. Beer's white precipitate. If the carbonyl group is present. If test, it gives pink or red color when aldehyde is present. Valence test is red precipitate when aldehyde is present. Volumetric test, we give silver mirror when aldehyde is present. Chromic acid test, we give in green or blue color in the presence of aldehydes. Sodium nitroproside test, it will give red color in the presence of ketone. These are the various tests for carbonyl groups. Let's look at the related compounds. The related compounds are chlorhyl hydrate, azamine, vanillin. So chlorhyl hydrate, it is shamyl diol. Formula is C2H3Cl3O2. Shamyl diol basically means where 2 hydroxy group is attached to a single carbon. Properties is colorless solid, soluble in water and alcohol, decomposes on methane. Yes, with strong base. It's a fluid. That is a double-headed properties. Next, look at the examine. It is also for urinary tract infections, also known as UTI. Vanillin is used as a fairy mutations in top rate, big coats, aspirin, mask and grazing flavors in medicines, mask bitter taste for medicines, and the cell women. Vision for the tannins in plant cells. Next is your electronic effects. First one is inductive effect. What is inductive effect? There is a polarization of sigma bond. Minus effect is electron withdrawing. There's a electron withdrawing group is there. It will withdraw the electrons from the oxygen chain, the carbon, plus the effect that is electron releasing, but this provides the electron to the carbon shape. Increases the solidity of ions. It is your inductive effect. Electromagnetic effect. It is temperature of 5 electrons under influence of a techno reagent, and it is temporarily polarized. So electromagnetic visible temperature for 5 electrons. Resonance, delocalization of 5 electrons. Hyperconjugation, it is delocalization of sigma electrons is your hyperconjugation. Resonance is delocalization of 5 electrons. So reactions, mechanism, assembly concepts. There's nucleophiles, nuclear slugging, an electron pair, it is delay space, and ionic neutral. So they are nuclear second, that is basically they move for positive charge because they have lots of negative charges, and the electronegativity is high. Either it is anion. Next is electrophiles. They are electron loving, except the electron pair, that is uric acid, and this titanium, that is containing lots of positive charge, and because electrons, you get nuclei. Bond fission, homolytic fission, that is homolysis, symmetric distribution and formation of free radicals. Homolysis, bending down of bonds. Hyperlative fission, this uneven distribution and formation of ions. So homolytic fission is basically breakage of bond between two similar atoms. Hydrolytic fission usually means breakage of bond between two different groups of atoms. Next is electron element arrow. The curved arrow is present. If it's 2 electrons, if half arrow is present, that means the electron is fast. And that's it for the mind map of carbonyl compounds. Aldehyde ketones test for carbonyl compounds, different compounds, Nucleophilic and reaction methods. Thank you.